All right, starting. So this is the formative review for the form assessment 2. Moving it over. So the first problem asks it asks you to write each radical expression in exponential form. So radical means that I have some kind of a root. So remember, radical means root. I want to change the radical into an exponential form, which has an exponent instead of a root. So right here, we're going to take a look at number 1. That is the 4th root of the 5th root of h. So when you're doing this problem, I'd focus on the inside first. So the most inside part is that 5th root of x. So change the 5th root of h into h to the 1/5. Now that's not the only thing that's going on. I have a 5th root inside. I also have a 4th root outside. So a 4th root outside, an exponential form would translate to an exponent of 1/4. So h to the 1/5 to the 1/4. Now when it comes to these kind of exponents, you've got h to the 1/5 to the 1/4. You need to multiply the exponents. So that the h stays there. Well, 1 times 1, 1, easy. 5 times 4 is 20. So I have written my radical expression into exponential form. So h, here you go, h to the 1/20th. Right, so that's the first one, not too bad. Second one, so that's 1 over the cube root of y. Now this one stresses out a lot of people because they're overthinking it. So that 1 can follow through, over. Remember, cube root of y, that is just y to the power of 1/3. The root dictates what type of exponent you'll have. If you've got a cube root, you got a 1/3. If you've got a 4th root, 1/4. 100th root, 1/100th. You could totally leave the problem like this. It's an exponential form. There's nothing wrong with it. Some people will go a step further. Remember, if you have 1 over an exponential expression, that's the same as saying y to the negative of that expression. In this case, you can change this to y to the negative 1/3. I would consider either expression as equivalent. This is more useful for I don't know, certain classes. This is more useful in my opinion in calculus and beyond. So either way works. All right, so I have changed both to exponential form. There are no more roots. The roots are gone. So this is good. Moving it along. Now, problems number 3 and 4 are asking for something different. You want to write them in radical form. This time I want the roots there. I need to have roots for this problem to be correct. Right. Number 3, don't overthink it. X to the power of 1/2. Well, 1/2 is a square root. That just means a square root. So change 1/2 into the square root of x. And then don't forget to bring the 7. And you could totally leave the problem like this. There's nothing wrong with that. If you wanted to make it nice and clean, you could get rid of the parentheses, I suppose. Like that. And then this works. So let's think about it. I want a radical. I have a root. Now that I have a root, it's good. You also want to make sure it's simplified as possible. So for number 4, this one's a little bit crazy, but not as bad as you think. So for number 4, you want to take a look at this. There's a whole bunch of junk inside this exponent thingy, and I want to deal with all that junk before I apply this. So let's deal with the inside. That's b to the 0 times b to the 4. Remember, when you're multiplying two exponentials, that means you're really adding the exponents. So 0 plus 4, that's just 4. So let's rewrite this as 0 plus 4, that's b to the 0 plus 4 is 4. Divided by. Let's also deal with the bottom part. So that's b times b to the 9th. Remember, if there's no number, that's a 1. And think about it. You got 1b multiplied by 9 b's. That makes a total of 10 b's you've multiplied. So that is b to the power of 10. And 1/5. Copy it over. Now, I wouldn't apply the 1/5 yet. I still want to make the inside as nice as possible. So b to the 4th divided by b to the 10th. Remember, when you have an expression like this, you are subtracting the exponents. So b to the 4th minus b to the 4 minus 10. That's going to be negative 6. So that's actually b to the negative 6 to the 1/5. Now, some people would see this as negative 1/6 and immediately start changing it to 1 over b to the 6th. I actually want you to slow down. Rather than change all this up, why don't we change the exponent now? So 1/5 is a 5th root, so change it to the 5th root of b, voice correct, b to the negative 6. Again, this is in radical form. It's pretty much simplified. You could totally leave it like this. If you do want to go a step further, then that would be 1 over 5th root of b to the 6th. So roots are kind of interesting. Roots are almost treated like exponents. Remember, a root is 1/5. So a root would actually follow the 6th to the denominator, and that one would stay there. So this is okay. This is okay. This might be like the most proper way just because, you know, it's one extra step after this. But either way works. So I've gotten rid of the exponential. Now if there's a root symbol, that's a square root, I have a root, 5th root. So I've answered the problems. Right, moving along to the next page. Now this is your solving part. This is the actual algebra of the algebra, like the algebra course. Anyway, so what we're doing is we're solving for x using inverse operations. So you can't just put an answer and not show your work because they want to show you your understanding of inverse operations. So for problems that have no real solutions, identify any extraneous solutions. So you can't just write no solution and hope to get credit. You must write the extraneous solution. So starting from number 2, I got square root of x minus 5 equals negative 9. Now, I'm trying to solve for my x. This minus 5 is in the way, so in order to cancel out that minus 5, I need to add 5 to both sides. Plus 5, plus 5. I didn't mess with that square root, so that square root of x comes down. Minus 5 and plus 5, they're inverses so they cancel out, equals negative 9 plus 5 is negative 4. Now off the bat, I immediately know that there is no solution. This is because I have an expression with a square root equaling a negative number. This is telling me that there is some number I can put into a square root that will output a negative answer. That is not possible. Whenever you have a square root expression equaling a negative number, you know that there is no solution. So I would write no solution. But even though there's no solution, if you just identify the extraneous one, we should know that this is a no solution problem. But yeah, it's an extraneous solution, so I do need to continue. Okay, we're changing colors. So here, I need to solve for that x, so I got to get rid of that square root, so I need to put a square on both. A lot of people will put a square and then forget something. You must put negatives in parentheses when you are applying exponents. Because if you don't, you're going to get the wrong answer. So square root of x and squared, square roots and squares cancel out. I get x. Oops. I get x. There you go. So I get x equals, so negative 4 squared. That means negative 4 times negative 4 is positive 16. If you did not put the negative in parentheses, you would get negative 16, which is not the extraneous solution. So I'm left with x equals 16. You can't just leave it like that. You must mark it as the extraneous solution. Extraneous solution. You can also just write the word extraneous. Actually, now that I think about it, if you write no solution, but still put the answer, it kind of automatically is considered the extraneous solution, so you don't necessarily have to write the extra step, but you either have to write no solution or extraneous, one of the two. You can't just leave it blank. Right? So 2 is extraneous. Interesting, we're starting at 2. So 3, that is square root of x equals 9. This one's a really, really easy one. It's a little interesting why this is coming right afterward. Down. So square root of x equals 9. The inverse of the square root is the square. So just apply a square to both sides. Square, square. Square roots and squares are inverses. They're gone. So you're just left with x equals 9 squared, which you can do in your calculator, Or 9 times 9 is 81. And I would just leave it like that. Yep, this one's very straightforward and really short too. All right, moving it along. Number 4. This one's a little bit more complicated. So something a little annoying about this paper, I don't like that the square root has gone over the equal sign. That should not be there. That's a lot better. All right. So this one's tricky because of all the 3's. So that's a large 3. Because the 3 is large, that means you've multiplied by 3. This little 3 is that cube root symbol. Though I can see that it kind of looks like 3 cubed, because that might throw some people off. But that's a 3. I'm multiplying by 3. So if I'm solving, I have to get rid of all the stuff on the outside of the root first before I deal with the 1. A lot of you will start to do minus 1 just because it's the easy part. Don't deal with minus 1. Got to deal with that 3 first. Divide out the 3. Divide out the 3. 3 divided by 3, that's 1, so they cancel out. I'm left with the cube root of x plus 1. Bring that down. Cube root of x plus 1 equals negative 15 divided by 3, that is negative 5. Cool. So I still can't do that minus 1 yet. I need to get rid of that cube root. How do I get rid of the cube root? I need to cube both sides. All right, let me change color to make it a little more visible. Cube root, not cube, cubing and cubing both sides. Cubes and cube roots are inverses. They cancel out. So I'm left with x plus 1 equals, oh, and this is something I forgot. Yep, I said put it in parentheses. I even forgot to do that. So negative 5 cubed, negative 5 times negative 5 times negative 5. If you're having trouble, oh cool, this is a new fun calculator I discovered that I had on the computer. So if I want to put this in the calculator, I would put parentheses negative 5 cubed. So I can either go to math to get cubed, but I prefer to put this symbol right here, that caret, exponent 3. Enter, and I get negative 125. So negative 125. Now I still need to finish solving it out. So now I can finally get rid of that plus 1 by putting a minus 1 on both sides. Minus 1 and minus 1. X comes down. I haven't touched it. Minus 1 and plus 1 are gone. Equals negative 125 minus 1. I have a negative number, and I put another negative on it. Like another negative thing. That makes it even more negative. So this is negative 126. Cool. Right? And then now for my last problem. So that's 1 minus the root thing equals 9. Well, so this one kind of throws people off. Because you're used to seeing the number after the root, not before. So this time you would get rid of the 1. You can get rid of the 1 because it's on the outside. Minus 1, minus 1. 1 minus 1, cancel out. The negative comes down. If there is a negative in front of whatever's left over, that negative needs to come down. If it's a plus, that's positive, don't worry about it. But if there's a minus, it must follow. So negative square root of 4x equals 9 minus 1, 8. Nice. This is where people would start to freak out. Oh, cool. I know that if there's a negative here, then there's no solution. But there's a negative on here, what do I do now? Well, this is one of the cases where a lot of people would overthink it and start to do 100 extra steps. This one, just move the negative to the 8. Square root of 4x equals negative 8. And this applies with all types of problems. For example, if I had negative x equals 4, then the answer to this problem is x equals negative 4. Don't put the 1 and then divide it. There's no point in doing that. It wastes a good 15 to 20 seconds. Cool. So now I've moved the negative over. I need to get rid of that square root. I get rid of the square root by squaring both sides. I'm going to put a square and, not to forget this time, parentheses squared. Square roots and squares are inverses. Cancel out. 4x comes down. Equals negative 8 squared. Negative 8 times 8, that's a positive 64. Positive 64. I'll divide 4 on both sides. 4 divided by 4 cancels out. X equals 16. So, one thing I did forget to mention, I actually can tell that there's an extraneous solution. So, let me go back to this part before it was covered by the lovely green. So, that part was square root of 4x equals negative 8. So, what did this part tell me? This part is telling me that there is something inside the square root that can give me a negative number. Remember, this is a no-no. If I have a square root, something in a square root equaling a negative number, I know that there should be no solution. So this is actually a no solution problem. No solution. And since this is no solution, that means x equals 16 is an extraneous solution. Let's just write that word, extraneous. So this is a misconception I noticed in class. A lot of people thought, oh, well, what if I have a negative with the cube root? Does this one mean I have no solution? No, if I have a negative with a cube root, I still have a solution. It only applies to square roots, fourth roots, sixth roots. Anything with an even number root would have no solution if you're left with this scenario. All odd roots, cubed, fifth, seventh, they all have solutions here. So don't immediately write no solution because you see a root with a negative. It must be a square root, a fourth root, a sixth root. And on this test, you're only going to see square roots anyway. So that's it. So cool.